Okay, this is training mission number 4. It's about conventional landing, which turns out is not so conventional for AV8B Harrier. So let's start.
Welcome to this training mission, in which we will go through all the elements of a successful conventional landing in the AV8B. As you know, the Harrier is capable of landing in a number of different ways, and the conventional version is not the most common of these. In fact, a combination of design characteristics make conventional landings more of a contingency procedure, generally only used if there is a suspected failure of the reaction control system. The airplane was not intended to be routinely operated this way, and the poor ground stability characteristics of the AV8B make the CL a less than optimal choice of those conditions. We'll begin this lesson with an overhead brake. The overhead brake allows you to get an entire 4-ship division on the ground as quickly as possible, and therefore is the standard landing procedure for most naval fighter jets. You will have an opportunity to do it 3 times during this sortie. Remember, it takes time to learn how to do it properly. We are currently flying towards the Kapoleti Airport, which is waypoint 1, at an altitude of 15,000 feet MSL. Once ready, we will descend to the pattern altitude for the overhead brake, which is 800 feet AGL, perform a touch and go, and then repeat the whole procedure twice, with the third landing being a full stop. Let me know when you are ready to start with some basic information and restrictions. Okay, we'll start with the operating limits. The maximum landing weight for the Harrier is 26,000 pounds. It is very unlikely that you'll be fully loaded with fuel and weapons on landing apart from emergency procedures, and even these will require you to jettison your ordnance anyway. Maximum speed at which you can deploy your landing gear or fly with the landing gear down is 250 knots. The maximum speed on the ground is 180 knots, so you'll want to be slower than that during landing. Also, remember that the air brake is not available when the landing gear is down. Finally, a word on crosswinds. The Harrier does not tolerate strong crosswinds during landing, and strict rules are in place because of that. All the numbers I will give you are for the paved runways with a minimum width of 100 feet. If the runway is wet, deduct 5 knots from the figures. The limits are as follows. For the approach speed equal to or above 140 knots, the maximum crosswind is 20 knots during the day and 15 knots at night. For the approach speed below 140 knots, the maximum crosswind is 15 knots during the day and 10 knots at night. Additionally, if your gross weight is above 19,550 pounds, all the crosswind values I just gave you should be reduced by a further 10 knots. Of course, it is possible to land with stronger crosswinds, and it has been done before, notably by our forces operating in Afghanistan. Still, quite a point. Now with all that out of the way, we are almost ready to begin our descent. Before we do, there is a short checklist that you need to go through. Ready? First, make sure that the stow stop is in clear position. Next, verify the weather information obtained via ATIS or from the tower. Pay special attention to the wind speed and direction, as well as the cloud ceiling and visibility. Taking all that into account, you will decide at this point on a suitable type of approach and landing. In this case, we already know that we will go for an overhead brake into a conventional landing.
Kapoleti, Dodge 1, inbound.
Next, prepare your instruments. Set your steer point to home plate, which is waypoint 1. Set up your TACAN. This will be covered in greater extent in the navigation training.
Caution, caution.
Press the TACAN or TCN button on your UFC and use the keypad to enter the channel 6-7. Press Enter or ENT when ready. Next, press push button 1 on the option display unit, or ODU, to select the TR, or transmit receive mode. Verify in the top left corner of your left MPCD that you see the bearing, distance, and time to selected TACAN station. It should be showing around 068 degrees. Make sure that the waypoint text next to push button 11 is boxed. If it isn't, go ahead and press push button 11. We will now set the approach course for Copoletti, corresponding with the magnetic heading of the runway we are going to use. We will land on runway 07, and the correct value for it is 064. Turn the course select knob and watch the data in the bottom right corner of the MPCD change. In order to have a better view, press push button 20 to change the scale to 25. You should notice a line appear in the top part of that screen. This line is the course you will want to intercept. Turn toward it and fly straight until you are above it, and then turn to heading 064. Performed correctly, both the bearing in the top right corner of the screen and the current heading in the middle of the screen should display the same value, and the line should be directly under your plane symbol. Configure your nav FLIR and HUD as desired depending on the time and weather. If the airport you are flying to is much higher than mean sea level, you may want to switch to radar altimeter display on your HUD. However, since Copoletti elevation is only 59 feet MSL, we will do that at a later stage. Check your fuel for any asymmetries. If these are greater than 300 pounds, balance both fuel tanks. Also, you may want to reset bingo bug to a brief setting, but we won't be touching it for now. As the temperature on the ground will be different than what you get at your standard cruising altitude, turn your cabin temperature controller knob to maximum in order to preheat the cockpit, and then put the defog switch in the max position.
Done.
During IMC landings and at night, at this stage you would turn on your APU. If your generator fails, the APU serves as a backup generator and would power essential systems. Obviously there is no need to do anything now, but we will be covering this in greater detail in the night systems lesson. Maximum speed at which you can deploy your landing gear or fly with the landing gear down is 250 knots. The maximum speed on the ground is 180 knots, so you'll want to be slower than that during landing. Also, remember that the air brake is not available when the landing gear is down. Okay, time to contact Copoletti Tower. Set one of your radios to 133.0 and inform the airport that you are inbound. Note down the QFE altimeter value given to you by the controller. As you pass 5,000 feet MSL, set the QFE on the altimeter as instructed by Tower. Also, switch your nav and anti-collision lights to on and set your landing light to approach. While you descend, let's go through the game plan for the rest of the sortie. I'll do the overview now, as once you begin the break, there won't be much time to go into detail. Ready? As has been mentioned before, we will perform an overhead brake. That means that you will arrive over the runway flying at 800 feet AGL and with a speed of 350 knots indicated airspeed. Once the end of the runway disappears from your view beneath the nose of the aircraft, you will make a 4G level turn to your right, reduce throttle to idle, and intercept 10 units AOA. You will hold that turn for 180 degrees until you are flying alongside of the runway but in the opposite direction, or 244 degrees magnetic. This part is called the downwind leg. You'll want to exit the turn at or below 250 knots and then descend to around 600 feet AGL. Once there, you will stay in level flight and perform the following landing checklist. Lower the landing gear, keep flaps in auto mode, check that the stow stop is clear and stowed aft, check for positive duct pressure, check that the brake pressure is 2700 psi with pedals depressed, and make sure that the water switch is set as required for landing performance. You will drive to between 1.3 to 1.5 abeam, which means around half the length of the runway beyond its starting point. And make sure that the nozzles are fully aft at 0 degrees and recheck that your flaps are in auto. Also, it is advised to switch to the radar altimeter at this point and enter the VSTOL HUD master mode. You should be slowed to 10 to 12 units of AOA at between 65 to 75% power. You will then turn towards the runway. For reference, use the 2 small lakes near the airport. You want to almost get to them. You will want to control the descent with your stick and the AOA with the throttle. Throughout the turn, you will be descending to an intercept approximately 500 feet AGL halfway through the turn at the 90, and 200 feet AGL when you roll out on final in the groove. Try to keep AOA between 10 and 12 units, and keep the speed below 180 knots. Don't go too slow. If you do, your AOA will get high. Finding the sweet spot here is the tricky part. At around 50 feet AGL, place the witch's hat at 2 degrees above the horizon. Continue to control your rate of descent with the throttle and attitude with the stick, and maintain 12 units of AOA. On a full stop landing, at touchdown you would set the throttle to idle and make sure that you're rolling straight with the pedals neutralized before engaging nose wheel steering. You would then set the nozzles for power nozzle braking, or P&B, trim for 2 degrees nose down, and set the throttle to 70%. However, as this will be a touch-and-go landing, immediately after touchdown, I want you to increase the throttle to full and allow the aircraft to take off again. That's about it. I will now let you focus on your approach. Make sure to align your aircraft with the course line, arrive over the runway at 800 feet and 350 knots, and fly straight until I tell you to turn. I will then be giving you abbreviated instructions.
Okay, let's try to be as precise as possible.
Dodge 1, cleared for visual, contact tower.
Okay, we are at 800, almost. More power.
Well done, you are within the approach parameters. Alright, 4G right turn, reduce throttle, intercept, and keep 10 units. Level off when running parallel to the runway. Good, descend to 600 feet, stay below 250 knots indicated, fly straight. Landing checklist, gear down, flaps auto, duct and brake pressure checks good, water not required, nozzles aft, warning and caution lights are out. Also set the master mode to VSTOL and switch to radar altimeter.
Where are radar?
Turn right again, try to keep AOA between 10 and 12 units. Aim at 200 feet for final approach.
altitude, altitude.
Perfect, but okay, acceptable for now.
Which is at to 2 degrees above horizon. Control descent with the throttle. You are on the ground. Good. Now increase throttle and take off.
Altitude, altitude.
You coming up.
Climb to 1,500 feet MSL, turn left to heading 250, and then continue on that course for 20 miles. So what do you think? Not as easy as it may seem, is it? We will perform another touch and go, then egress again and go for a full stop after the third overhead brake. When you are far enough, turn back towards Capoletti, align with the runway, and try the whole procedure once more. If you like, I can repeat the long version of the instructions for you.
Oh, that will do. Okay, let's turn.
Alright, 4G, right turn, reduce throttle, intercept, and keep 10 units. Level off when running parallel to the runway.
Too much.
Good, descend to 600 feet, stay below 250 knots indicated, fly straight. Landing checklist, gear down, flaps auto, duct and brake pressure checks good, water not required, Nozzles aft, warning and caution lights are out. Also set the master mode to VSTOL and switch to radar altimeter. Turn right again, try to keep AOA between 10 and 12 minutes. Aim at 200 feet for final approach.
It's too high. It seems like it's not going to turn
Altitude.
without higher AOA. Need also to descend.
Which is at to 2 degrees above horizon. Control descent with the throttle. You are on the ground. Good. Now increase throttle and take off.
Altitude. Altitude.
Climb to 1,500 feet MSL, turn left to heading 250, and then continue on that course for 20 miles. Good. Repeat the whole process, but this time after landing you will slow down and taxi to the parking spot. After landing, use your nozzles to decelerate. Remember that the wheel brakes above 60 knots can only be used as an emergency when the PNB is not available. For nozzle brake, set the nozzles to braking stop position, increase your throttle to 60%, and then add some power to reach 70. Once you are rolling straight and the pedals are neutralized, engage the nose wheel steering. Below 60 knots, reduce the throttle and set the nozzles back to 0 degrees. If you have to use the wheel brakes, as the nozzle brake is not possible, make sure that the rudder is neutralized and you are rolling straight. Press the brakes 2 seconds after touchdown and keep them pressed. Do not pump them.
Okay. This is the final attempt.
Alright, 4G, right turn, reduce throttle, intercept, and keep 10 units. Level off when running parallel to the runway. Good, descend to 600 feet, stay below 250 knots indicated, fly straight. Landing checklist, gear down, flaps auto, duct and brake pressure checks good, water not required, nozzles aft, warning and caution lights are out. Also set the master mode to VSTOL and switch to radar altimeter.
Okay, good so far. More altitude and more power.
Right again, try to keep AOA between 10 and 12 units. Aim at 200 feet for final approach.
Yeah, it's just I think I need to be more
Altitude.
towards the lake to come aligned better, but it's fine for now. It will work, I hope.
Which is hat to 2 degrees above horizon, control descent with the throttle. You are on the ground, good. Now, okay, you are on the ground. Set nozzles to braking stop position and increase your throttle to 60%, then add some power to reach 70%. Once you are rolling straight and the pedals are neutralized, engage the nose wheel steering. Trim the nose 2 degrees down. Now you can apply the brakes and reduce the nozzle angle. Slow down to a comfortable speed and taxi to the parking spot outside the tower. Use that last lane to the right.
Dodge 1. Taxi to parking area.
I'm sorry, but where's the tower? Tower is local. Pretty far. So the braking with the nozzle is not working very well, but no worries.
Once you clear the active runway, you should trim the nose to 4 degrees down, set the flaps to cruise mode, and ensure the water is off.
Flaps to cruise. Water is off.
Ensure that the master arm switch is off, turn the oxygen switch, APU, and the landing lights to off.
I don't know, should I park here?
Caution, caution. Caution, caution.
Anyway, so pretty much that's the landing mission. Usually works fine, but you still need to be between the gates of the trigger system, otherwise it will just not pass to the next stage and you can get stuck. Like now probably is expecting me to be near the other tower, although it's, he said to turn here, right. So I don't know, I'll just taxi to the other spot for the startup. Maybe that's the spot he's expecting me to go, but there are no further instructions, so I'll park there and then call it a day. So this is the daylight landing training mission, and there is also a night landing mission.
All right, choose one of the parking spots and let me know when you are ready to go through the shutdown procedure.
Okay, so let's choose a spot. How about this one with these two guys here?
Set nozzles from 0 degrees to 10.
We are at 10.
Set the parking brake.
Set.
Set the anti-skid to on position.
In.
Set flap mode switch to auto or middle position and flap power switch to off or right position.
Blast failure.
Set the DP switch to auto.
Is set. Déjà.
Set FLIR switch as desired.
Let's turn it off.
Set the INS selector to off position.
Caution, caution. Caution.
Set throttle
caution.
to off after at least 1 minute of running in idle so that the temperatures can stabilize.
Okay, let's call it 1 minute.
Set fuel boost
Caution,
pump switches
caution.
to norm position.
They are on norm.
Set the DEX enable switch to off.
Caution, caution. Fuel control, fuel.
Set the fuel shutoff handle to off.
Yeah, this is not doable by...
Set the battery switch to off.
They put a safety here, so you cannot do it by accident. You have to map it, but it's really only for the shutdown.
That's it. You have performed a successful conventional landing using the overhead brake. In the next lessons, we will cover other more common types of landings.
Okay, so it works. As I mentioned, just the fact that you have to be within the gates, but this is just a DCS limitation, and maybe some instructions here and there. The whole simulator needs some AI to actually monitor you while you do the training, because this trigger system is really ancient by now, but it's what it is for now.